In this video, we're going to be talking about rational functions, finding the domain of a rational function, and then we're also going to talk about vertical and horizontal asymptotes. So rational functions are of the form f of x equals n of x divided by d of x. So we're saying that there's a function on the top divided by a function on the bottom, and this creates a new function. So let's look at an example. Here we're being asked to find the domain of f of x equals 1 over x, and we're going to discuss the behavior of f near any excluded values that we might have. So let's take a look at this. If we graph this, we get something similar to this. Notice the red lines. Our red lines are our function f of x equals 1 over x. Notice the blue dashed line. The red never gets to it. It gets close, but it never actually touches it or crosses it. And our green dashed line, same thing. Our function, our red line, gets really, really close, but it never actually touches it or crosses it. So as we look at our domain, we notice that x could really be all real numbers. Looks like it goes all the way to negative infinity, all the way to positive infinity, except it never crosses the y-axis, which means that x can't be 0. In fact, it looks like y can actually never be 0 as well. And this is what brings up our asymptotes. So let's talk about these a little bit more. So vertical asymptote, I'll be using VA for short. Let's take a look at a graph right here. So this is looks very similar to what we might see as a tangent function. And when we graph a tangent function, we have these places where the graph never gets to. It gets close, but it never crosses it. It's never actually that value. These are what we call vertical asymptotes because the asymptote is vertical. And this is going to be x equals some number. So it means that our x can approach from the right or it can approach from the left, but it never actually gets there. Let's talk a little bit more about horizontal asymptotes. So I'm going to call that HA for short. So let's take a look at this graph right here. So notice that our graph never really gets to our blue dashed line. It gets close, but it doesn't ever get to it or cross it. This is a horizontal asymptote because it goes from left to right. An equation for a horizontal asymptote would be y equals a specific number. So now, how do we find those equations? How do we know what our vertical asymptote is, our x equals, and how do we know what our horizontal asymptote, or our y equals, is? We're going to go ahead and we're going to do an example. All right, so let's see. So we're going to find all of the asymptotes of the graph of each of these rational functions. So we'll start with example A, which is f of x equals 2x divided by 3x squared plus 1. So we'll find our vertical asymptote by taking our denominator and setting it equal to 0. So we're going to take our 3x squared plus 1, and we're going to set that equal to 0 and solve. So that's going to give us a 3x squared equals negative 1, divide by 3, so we're going to get x squared is a negative 1/3. And then when we square root that, we see that we're going to have an imaginary number. And what that tells us is that there is no vertical asymptote. There's no vertical asymptote. Now, a horizontal asymptote works a little bit differently. So here, we're going to be involving both the numerator and the denominator. And there's kind of 3 different situations. So we can kind of cut it down into 2 different thought processes. So what we're going to do is we're going to look at the degrees. So here we have an x squared, and here we have an x. So we want to see which degree is larger. Here we have basically a degree of 1, and here we have our degree of 2. And because our denominator is bigger, then we know that we're going to have a horizontal asymptote. If my numerator's degree was larger than the one in the denominator, then there would be no horizontal asymptote. So let's get back to this. What we're going to do is we're going to go ahead and we're going to rewrite this. Now on the denominator, we have our 3x squared plus 1, and we have our 2x, but we want to write this so that it has an x squared term. So we'd have a 0x squared added to the 2x. And 0x squared still means 0, and so we're just fine doing what we're going to do. Now to find that horizontal asymptote, we are going to look at the leading coefficients of our numerator and denominator. So again, we're comparing these because their degrees are the same. So I'm going to go ahead and I'm going to take these front pieces. So my horizontal asymptote is going to be whatever 0 divided by 3 is, which is 0. So my horizontal asymptote is y equals 0. So let's try letter B. So we have f of x equals 2x squared divided by x squared minus 1. So if we look at our vertical asymptote first, we're going to take the x squared minus 1, we're going to set it equal to 0, and we're going to solve. So we'll add 1 to both sides, get x squared equals 1, we take the square root of that, and that's going to give us x equals a plus or minus 1. So I'm able to say that my vertical asymptote, that I have 2 of them. I have x equals 1 and x equals negative 1. So I have the line x equals 1 and I have the line x equals negative 1. If we look at our horizontal asymptote, I can see as I compare my 2 degrees that they're the same, which means I don't need to put in a filler like the 0x squared like we did over here. We're not going to need to do that this time because they already are equal. So because they're equal, I'm going to go ahead and write those out. So I'm going to have a 2x squared over x squared minus 1. Now remember, in front of that x squared is an imaginary 1, right? So then we're going to go ahead and box these just like that. So we see that our horizontal asymptote is going to be whatever 2 divided by 1 is, which is 2. So our horizontal asymptote is going to be y equals 2. And so now we've found all of our asymptotes for our problems. And it's usually a little bit better if you write them down together so you can keep them close by. So we'll just go ahead and put our answer for A and put y equals 0. And now we've got those answers easy to find, to be checked. Now really quickly, I just want to put a quick little if in there. If, as I had done these, let's say I have a different one, right? And I have the f of x equals, and I had something like 3x to the third over 2x squared. Then, if I was finding my vertical asymptote, we know what we would do there. We would take that 2x squared, we would set it equal to 0, and that would give us that x equals 0, right? So our vertical asymptote would be x equals 0. But for our horizontal asymptote, we'd look at it and go, gosh, our 3 is bigger than our 2, which means that we can't do it. So here, for our horizontal asymptote, we would have none. Okay, so our vertical asymptote would have been x equals 0, and our horizontal asymptote would have been none. Again, it would have been none because my numerator's degree is larger than my denominator's degree.